Hey everyone, welcome. Today, we're going to dive into what it actually takes to build AI that works out there in the real world. We're going to cover the whole journey, from that first spark of an idea to prepping the data, all the way through training and deploying the model. Because here's the thing, creating a brilliant AI model isn't the finish line. Nope, it's just the starting gun for a much, much bigger race.
We had this romantic idea of AI development, right? We picture some genius data scientist in a lab having this one big eureka moment. But the reality? Oh, it's so much more, well, industrial. Building and running AI at scale isn't about one single moment of brilliance. It's about building an entire factory. It's an assembly line for models that has to run like clockwork, day in and day out.
So before we can even start building this factory, we've got to ask, what problem is it even designed to solve? Well, it's designed to solve the messy, complicated, and often frustrating reality of AI development. It's a process that's just filled with all these hidden challenges that we absolutely need to understand before we can even think about building anything.
And to really get our heads around that mess, we need to take a hard look at the typical machine learning project cycle. I mean, on the surface, it looks like a pretty straightforward blueprint, but in practice, let's just say it's less of a straight road and a lot more like a tangled, frustrating loop that you can get stuck in.
Okay, so look at this. The first thing that probably jumps out at you is that this is not a straight line. Not at all. You start by defining a use case, you analyze the data, you pick a model, you engineer features, but then, once you finally get it deployed, you have to monitor it and retrain it, which throws you right back to the beginning. It's this continuous 8-step loop, and every single one of those steps is a place where things can go wrong.
Let's kick things off with the most fundamental challenge there is, your data. I mean, if your training data is a mess, full of errors, weird outliers, or missing values, your model's performance is just going to tank. It's that classic old-school programming principle. Garbage in, garbage out.
Next up is underfitting. So, this happens when your model is just too simple to capture the actual complexity of your data. Think of it like trying to draw a straight line through a really curvy, winding road. You're just going to miss the pattern completely, right? The model just isn't powerful enough for the job, and it's going to be inaccurate on pretty much everything you show it.
And then, wouldn't you know it, you've got the exact opposite problem: overfitting. This is where your model learns the training data way too well. It basically memorizes not just the important signals, but all the random noise too. So while it might look like a total genius on the data you trained it on, it fails spectacularly the moment it sees new real-world data.
And of course, let's talk about the money. Training these powerful models requires a just staggering amount of compute power. We're talking expensive GPUs, TPUs, entire server farms. Honestly, the budget for just experimenting to find a good model can be this massive financial hurdle before you've even really gotten started.
So you're sitting there looking at this, right? You've got this loopy, iterative process. You have these constant threats from bad data and wonky model performance. And on top of all that, it costs a fortune. So the question is, how on earth does any team manage to do this reliably and at scale? How do you build that factory without the whole thing just collapsing in on itself?
Well, the answer, the way we bring order to all that chaos, is a discipline called MLOps, which stands for Machine Learning Operations. It basically takes all these battle-tested ideas from software engineering and applies them directly to the very unique challenges of the machine learning lifecycle. The whole goal is to bring some much-needed order and predictability to the process.
To put it simply, MLOps is the blueprint for our AI factory. It's all about making that journey from a cool idea to a real-world model something that's repeatable, reliable, and efficient. It standardizes the whole workflow so the teams aren't constantly reinventing the wheel, which lets them build way faster and with a lot more confidence.
But here's the catch. You don't build a fully automated factory overnight. It just doesn't work that way. See, adopting MLOps is a journey. Most organizations move through these really distinct levels of maturity, starting from a process that's completely manual, and then gradually, step by step, adding more and more automation.
And pretty much every team starts right here, at level 0. This is the manual lab. Every single step, pulling data, training the model, checking if it's any good, and deploying it, is done by hand. It's all ad hoc, kind of held together with duct tape and hope. Sure, it might get your first model out the door, but it's slow, super error-prone, and absolutely impossible to scale. Now, at level 1, this is where things start to get interesting. We get our assembly line.
If you look at the diagram, that whole central process, from validating the data and training the model to registering it, is now an automated pipeline, and that is a huge leap forward. It means you can consistently and rapidly retrain your model on new data, and that removes the most time-consuming manual bottleneck of all.
And this, right here, this is the Holy Grail. Level 2, the fully automated factory. This diagram shows a full CI/CD or continuous integration and continuous deployment system, and notice that feedback loop at the bottom. The monitoring service can actually detect a problem out in the real world, which automatically triggers a brand new training run through the entire pipeline and ultimately deploys a new, better model, all without a human ever touching it. That, my friends, is the power of a true AI factory.
Okay, so that's the theory, that's the dream. But how do you actually build this factory without getting totally bogged down in all the underlying infrastructure? Well, this is where platforms like Google's Vertex AI come into play. It gives you a whole set of powerful, pre-built tools that are designed specifically to put these MLOps principles into practice.
Let's just connect the dots here. To orchestrate that automated assembly line we were just talking about, you use Vertex AI pipelines. To keep track of all your different model versions, you have the model registry. Need to manage and reuse data features across your team? Well, there's the feature store for that. And to watch for performance problems in the real world? That's what Vertex AI monitoring is for. See? Each core MLOps need is met with a specific tool, letting your teams focus on building great models, not the plumbing.
All right, so let's tie all of this together. We started with the messy reality of AI. We saw how the whole philosophy of MLOps can bring order to that chaos, and we've seen the actual tools that make it possible. So what's the single most important idea to take away from all of this?
It really boils down to this one simple idea. A groundbreaking, genius algorithm that's just sitting in a data scientist's notebook, well, it's just an academic exercise. The real value, the real magic of AI is only unlocked when you can actually deploy that model, monitor it, and maintain it reliably in a production environment. MLOps is what turns a brilliant model into a powerful, real-world machine.
And so that leaves us with one last kind of huge question to chew on. We are getting incredibly good at building these powerful AI factories that can produce intelligence at an industrial scale. So if we have this amazing new factory, what is the most important thing that we as humanity should choose to build with it first? That's something to think about. Thanks so much for joining me on this explainer.